In this video, we're going to look at another model which involves speed and traveling. So let's read the problem first. It says John and Mary are driving westward along I-76 at constant speeds. So constant speed just means there is no acceleration. There is no acceleration. And when you have no acceleration, if you plot your position with respect to time, it always comes out to be a straight line. So it says that there are two graphs here and they show the distance on the y-axis in miles that they travel from Philadelphia at time x in hours, and x equals 0 is noon. Now one thing to notice here, as I mentioned, is at noon we are saying that John has already traveled 150 miles, whereas Mary is just beginning to move, right? So the first problem says, at what speeds are John and Mary traveling? Now for that, we are going to use the definition that speed is distance traveled over time taken. Now if you think about this, what this really means is it's the change in position, that is the y value, divided by the change in time, right? Because if you go from A to B, there is, if I call this 0 and B 5, then the change is 5 minus 0, which is 5, which gives you exactly how much distance you travel. Now this expression, change in position over change in time, that's simply the rate. And what is rate? Rate, we have established, is slope of the straight line. Okay, so in order to find the slopes for John and Mary, we just need to select some points. And it looks like they have, for convenience, selected some points for us. So for Mary, the 2 points are at 2, she's at 150 miles, and at 4 she's at 300 miles. So the slope is 300 minus 150 over 4 minus 2, which is 75 miles per hour. So that's her average speed. What about John? For John, let's say at 2 it is it's about 250. So the reason it's more is because, remember, at 0 John is already at 150, and at 4 John is at 350. At 4 John is at 350. So the slope for John, which is to say his average speed, is actually 100 over 2, so it comes out to 50 miles an hour. Consequently, who is traveling faster? Mary. And you can see, although Mary starts at 0, she kind of catches up with John over time, and that's because the slope is larger for Mary than for John. So that's part A. Part B says find function that models the distance that John and Mary have traveled as a function of x. So part B is basically finding the equation of those lines, and they are going to be the model. So for Mary, we take y minus y1 and the slope 75 and x minus 2. Simplifying this a little bit gives me 75x minus 150, which gives me y equals 75x, which again makes sense because it's a line that goes through the origin. So it's of the form y equals mx. Now what about John? For John, we will not expect a y equals mx form. For John, we have y minus 250 is slope, which is 50, x minus 2, which is y minus 250 is 50x minus 100. So I add 250, add 250, so I get y is 50x plus 150, which you can verify when x is 0 is 150, which is what the graph here shows for John. Part C says, how far will John and Mary have traveled at 5 p.m.? Now, for that you have to remember that time is being measured from, so x equals 0 was noon, which means 5 p.m. is going to be x equals 5, 5 hours later. So Mary would be 75 times 5, which is 375 miles away, whereas John would be 50 times 5 plus 150, which is 300 miles. Oh, sorry, 250 plus 150 is 400. Yeah, that did not sound correct. Says, for what time period is Mary behind John? Will Mary overtake John? If so, at what time? This is a very interesting question. If you look at part C, we can see that Mary is now only 25 miles behind John. That's at 5 p.m. Now, what does it mean for them to meet? What does it mean for them to meet? To meet means that their position on the graph coincide, so that if this is Mary and this is John, they intersect at some point. Okay, so this is Mary and this is John, and that would mean that before this intersection point, at whatever time it happens, John is ahead of Mary, and then after that, Mary is ahead of John. So finding that point basically amounts to solving these equations. So what we're saying is, when is y equals 75 same as y equals 50x plus 150? So that happens if 75x equals 50x plus 150, or 25x is 150, or x is 6 hours, which means at exactly 6 p.m. Mary will overtake John. Okay, so that's what this problem is asking. So for the time period that is before 6 o'clock, so for about 6 hours, Mary is going to be behind John, and after 6 hours, she will overtake John, and then John can never overtake, because these are straight lines, it's a linear motion. And intuitively that makes sense, because although Mary starts almost 150 miles behind, she is traveling on an average faster than John, and she's traveling faster by 25 miles an hour. So even by a direct calculation there, she has a 25 miles per hour advantage in terms of speed and a 150 mile disadvantage in terms of distance. So to cover up that distance, it would take her exactly 150 over 25, which is 6 hours. So that's another example of a linear model. So how you can have two models which are linear, and by solving them you can get information about these models. We're going to look at more examples for rate of change, because that's an extremely important concept in calculus, and that's going to be in the following videos.